The good molecules of the cell have been on edge for days. The cell has always been a vibrant place to live and work, but that is all in jeopardy now due to threatened walkout by the Transport Protein Workers Union, which has been unable to secure a satisfactory contract from the Cellular Membrane Transportation Authority, more commonly known as CEMTA. CEMTA oversees all businesses at the plasma membrane, which forms the outer border of the cell. The plasma membrane insistently bustles with the activity of molecules entering and leaving the cell. Much of that activity is critical, and it is not known how severely a strike by the TPWU will affect life at the cell. Many molecules are tuned in their local TV news stations, desperate to hear the latest, and the following breaking news report interrupts the regular scheduled program.
Good morning. This is Phil Lippitt in the newsroom at Channel 2 Organic News with a live special report. The Transport Protein Workers Union, or TPWU, has just had a press conference where they announced that they will strike at midnight tonight. Negotiations between the TPWU and the CEMTA have broken down and no new talks are scheduled at this time. Chloe Estrall is standing by at the plasma membrane. Chloe, what's the latest?
Good morning, Phil. Talks with the TPWU have indeed broken down as of 10 a.m. this morning. Those talks were reportedly marked at times as heated and occasionally emotional exchanges from both sides. The TPWU has announced that they will strike beginning at 12 midnight. What that means is that all transport through any type of transport protein, whether by diffusion, facilitated diffusion, or active transport, will be shut down at midnight. The phospholipids, who are represented by a different union, will remain on the job. As a matter of fact, the phospholipids are directly behind me. You can probably hear them now because, as you know, when the phospholipids are at work, they are constantly chattering and chanting.
We are phospholipids. We are part of the plasma membrane. We let some things pass through, but other things cannot. Some things can pass, other things cannot. Some things can pass, other things cannot. Some things can pass, other things cannot.
The phospholipid chants, of course, have to do with their selectively permeable capabilities. And as I've already stated, the phospholipids are expected to remain on the job in the event of a strike by the TPWU. Now, the TPWU is asking for better working conditions. They say they work long hours without a break. They say they have difficult jobs, shuttling important molecules across the plasma membrane. And quite frankly, they feel they are not adequately rewarded for their efforts. Some transport proteins have claimed that phospholipids receive all the attention and enjoy much better benefits due to their sheer numbers. Earlier, I caught up with Polypeptide, president of the TPWU, and this is what she had to say. Do you realize the dramatic effect a strike at the plasma membrane would have on the cell?
We do, but given the extreme pleasure we are under, we feel this action is warranted. Our transport proteins work hard day and night and day. We are reliable. We're always there taking care of business. We deserve better working conditions and a lot more respect for our dedication and our vital role in membrane transport operations. That's it.
Phil,
Yes.
this morning I also spoke with some of the molecules that would be affected by the strike. Here's what they had to say. What is your name?
Well, I'm a water molecule.
How will you be affected by a TPWU strike?
Well, I use diffusion, but I'm small enough to cross a plasma membrane directly through the phosphid bilayer, so I can get back and forth that way alright. My problem would be the quad porins. If they shut down, I could be in trouble.
Interesting. Hello. Would you like to give our viewers your opinion on the strike? Yes, hello. I am carbon dioxide. I enter and leave the cell by diffusion. I can pass directly through the lipid bilayer. So, you will not be affected by the strike? No. And you are?
I am oxygen, and I also enter and leave the cell by diffusion. I can pass directly through the lipid bilayer, just like my friend CO2.
We
can pass
it
anytime. Yeah!
They see me rolling.
Stop.
They hate
My name is glucose. I enter and leave the cell by facilitated diffusion. So I must have a transport protein to cross the plasma membrane. You know, my transport protein recognizes me, and only me, no one else. It's like having my own personal interest. All the protein glucose molecules do.
And you? I am an amino acid. I get across by facilitated diffusion. My transport protein knows me and lets me through like that. No one else uses my transport protein. I'm needed in there. A strike will be a real hardship. Phil, obviously, a strike by the TPWU will be very disruptive to cellular activities. That can only be avoided with a return to the bargaining table. And this time, no meetings are scheduled. This is Cholesterol, reporting live for Channel 2 Organic News. Back to you, Phil.
Thank you, Chloe. Now, to get an objective viewpoint on the consequences of the strike, we have with us live feed Professor Kai Tossel of Cell University. Professor Tossel, welcome. We appreciate you taking the time to speak with us today.
Well, thank you, Phil. Glad to be here.
Professor Tossel, can you explain to our viewers exactly what impact a strike by the TPWU will have on the cell and its operation?
Well, we know the strike will have a direct impact on several major functions within the plasma membrane. These functions will include diffusion, facilitated diffusion, and active transport.
How will diffusion be affected? I thought diffusion involved the phospholipids only, which are not part of the strike.
First of all, diffusion is the passive movement of molecules from an area of high concentration to an area of low concentration. While it is true that diffusion can occur directly through the lipid region of the bilayer, some, but not all, substances cross that way. Most ions, for example, require a type of transmembrane protein called a pore or channel. They can't move directly through the phospholipids. What? Water, of course, is very important. Small amounts of water can pass directly through the phospholipids, which shift some about due to the fluidic nature of the bilayer. Water also passes through aquaporins, special water channels that are transmembrane proteins. In fact, this is the main route for water entering and exiting the cell. The aquaporins are critical for osmosis to occur.
You mentioned osmosis. What is osmosis exactly?
Well, osmosis is the passive movement of water through the plasma membrane. It occurs to keep a constant balance of water in the cell relative to its environment.
I never knew that.
Yes.
You mean water will move into and out of the cell depending on external conditions?
Yes. If the cell is in hypertonic conditions, then there is too much of some substance, for example salt, outside the cell, but not enough water. Therefore, water will leave the cell until a balance is achieved. If the situation is extreme, too much water may leave the cell and it will shrivel and die.
We all remember the great dehydration scare a few years ago when a stomach virus took its toll, affecting cellular communities far and wide. So, those were hypertonic conditions?
Yes, of course, the stomach virus was quickly eliminated, but osmosis is critical to maintaining the water balance. Now, under hypotonic conditions, we have the opposite situation. Excess water floods the cell, causing it to expand. Too much of this, and the cell could burst, killing it instantly.
Professor, the scenarios you are describing seem to mean dire consequences for the cell unless the strike is averted.
Yes, Phil. I would have to agree with your assessment. Ideally, we want isotonic conditions, which is a nice balance of water on both sides of the plasma membrane. To achieve that, the aquaporins must function properly.
Is there anything else our viewers should know?
Well, if the strike does proceed, facilitated diffusion would be another lost service.
What process does facilitated diffusion entail?
Facilitated diffusion is the passive movement of molecules across the plasma membrane that is aided by transport proteins. Without facilitated diffusion, large and important molecules like glucose and the amino acids can't get into the cell.
That would be very bad, for obvious reasons. Professor, everything you've discussed so far has been described as a passive movement. Why do you call them passive?
Because they don't require energy. Diffusion, facilitated diffusion, and osmosis are all passive because the cell does not use energy to drive the process. Active transport, however, does require the cell to expend energy, usually in the form of ATP. Energy is needed whenever a substance must move uphill against the concentration gradient. That is to say, from an area of low concentration to an area of high concentration. Phil? That's very nice, isn't it? It's very interesting. It's all very interesting. Isn't it, Phil? Isn't it, Phil? It's all very interesting.
And what does active transport require the use of transport proteins?
Yes, it does. So, this is yet another function that would be lost during the strike.
What kinds of molecules cross the plasma membrane by active transport?
Sodium for what? The sodium-potassium pump, for one, is a transport protein that needs ATP to run. That's a type of active transport that moves sodium and potassium ions across the plasma membrane. Regulation of sodium and potassium concentration is critical to the survival of the cell.
Well, this has been very enlightening. It seems that the cell could be in a great deal of trouble if the transport protein workers are on a strike. Wait. Thank you for your time, Professor.
You're welcome, Phil. Glad I could help.
We now return to our reporter, Chloe Estrall, live at the plasma membrane with an important update.
Phil, just moments ago, the TPWU and the CEMTA announced that they will return to the bargaining table at 3 p.m. There is hope that they will be able to reach an agreement and avert the proposed strike that could be a devastating outcome for the cell and its molecules.
Some things can pass! Other things cannot! Some things can pass! Other things cannot!
As you know, the situation here at the plasma membrane is very tense. Many molecules could be stranded on either side of the plasma membrane if there is a strike. Molecules are worried about how they will get into and out of the cell if the transport proteins are not operating.
Some things can pass! Other things cannot! Some things can pass! Other things cannot!
Here is a molecule on its way to the cell now. You look concerned. How will you handle the strike?
Being an oxygen cell molecule, I can cross the plasma membrane. The problem is what kind of chaos I will find once I get inside the cell. I mean, cellular respiration requires both myself and glucose. If glucose can't get in, how can I do my job?
Phil, a lot is resting on the continuation of talks between the TPWU and the CEMTA. This is Cholesterol, Channel 2 Organic News.
Thank you, Chloe. With us now is Mr. Gene Gnome, spokesperson for the cell. Thank you for joining us today. Please, call me Gene. Okay, Gene it is. Gene, what is the cell doing to avert a strike? Phil, the cell is accurately aware of the magnitude of the situation. We have been present during talks with the TPWU, and we will again return to the table as talks resume shortly. Specifically, what must happen for the TPWU and the CEMAT to reach a compromise and avert the strike? The cell has always had a strong belief in fairly compensating all of our cellular workers. We believe that it is the best interest of all involved that a strike be averted, and we firmly believe that an argument can be reached in time for that to happen. Jean, thank you again for your valuable time. You're welcome, Phil. Once again, the TPWU and the CEMAT have announced a return to the bargaining table in attempt to avert a strike scheduled to begin at midnight. We will continue to bring you live updates as information becomes available.
Well, at 9:35 p.m., a live press conference was broadcast to the molecules of the cell announcing a resolution between the Transport Protein Workers Union and the Cellular Membrane Transportation Authority.
We have just heard a live press conference where it is announced that the strike has been called off. The TPWU has agreed to contact with the CEMTA. Reporter Chloe Esterol is live at the press conference.
Phil, the TPWU has announced that they will sign a new contract with CEMTA. All of the details of that contract have not been released yet, but according to Jean Nome, spokesperson for the cell, a major part of the agreement involves a collaboration between the cell and CEMTA to ensure that the transport proteins receive the attention and recognition they deserve in all biology textbooks. So, in effect, biology students everywhere will learn about the vital role of transport proteins in the plasma membrane and their importance to operations in the cell. This is Cholesterol reporting live on the edge of the plasma membrane. Channel 2 Organic News.